After this lesson, students will be able to use measures of central tendency, such as mean, median, and mode, as well as range, in order to describe a set of data. Do now. The following are student scores from a pop quiz. Find the mean, median, mode, and range of the data. Pause the screen to try this on your own and see what you remember from previous years, and resume when you're ready. Let's start with the mean. A mean is like an average. To find the average, we add up each of the data points and divide by the total number of data points. So for the mean, I would add 10 plus 9 plus 8 plus 9 plus 8 plus 10 plus 2 and divide by the number of data points. 1, 2, 3, 4, 5, 6, 7. We get 56 over 7, which equals 8. So the mean would be 8. To find the median, we need to organize the data from least to greatest, and then find which data point falls in the middle. So from least to greatest, I've got the 2, next is 8, and another 8. Then we have 2 9s, followed by 2 10s. I count to make sure that I didn't miss any or put any twice. So 1, 2, 3, 4, 5, 6, 7 data points, just like I had before. And now to cross them off and find the center point, I do my first and last, second and second to last, third and third to last, and I have one left, which would therefore be the center point. So our median is 9. The mode is the most popular answer, or the number that occurs the most. You can have no mode, you can have one mode, or you can have more than one mode. In this case, the number 8, 9, and 10 each appear twice. So our mode would be 8, 9, and 10. Finally, we have the range. Range is the biggest number subtracted by the smallest number. So our largest number would be 10, our smallest is 2, so the range would equal 8. Measures of central tendency are mean, median, and mode. Mean, or average, is the sum of the data items divided by the total number of data items. I always remember the mean as being the meanest problem to do, since it is the most involved. The mean should only be used when there are no outliers in the data. An outlier is a data value that is much higher or lower than the rest. For example, if I give a quiz in class and 20 students get 100% on it and 2 students get a 50% on it, the average would not be used to describe our class data. Those 2 students that got a 50% would drag down our average. Instead, it would be more beneficial to use the median or the mode to describe our class data as being typically 100%. The median is the middle value in the set when numbers are arranged from least to greatest. When there are an even number of data items, the median is the mean, or average, of the 2 middle data values. For example, if we have 5, 9, 8, 10, 4, 7, 8, and 6, we have 8 data points. we begin by organizing them from least to greatest. So our smallest number would be 4, followed by 5, followed by a 6, and then a 7. We have 2 8s, a 9, and a 10. I now begin to cross them off from the outside. First and last, second and second to last, third and third to last. Now if I were to cross off the fourth and fourth to last, I would have no data points left. So instead, I have to take the mean of the 2 remaining numbers. As we mentioned before, the mean is the sum of the data items divided by the total number of data items. So I would do 7 plus 8 divided by 2, since I'm just taking the mean of the 2 remaining data points. This gives me 15 halves, or 7 1/2. The mode is the data item that occurs the most times. It is possible for a set of data to have no mode, one mode, or more than one mode. Use the mode when the data is non-numeric or when choosing the most popular item. For example, I would use the mode if I were to survey the class and ask which is their favorite flavor of ice cream, chocolate, vanilla, or strawberry. The mode would be the most popular answer, and I would use this because it's non-numeric or because I'm asking for the most popular item. Find the mean, median, and mode of the data in the line plot below. Which measure of central tendency best describes the data? First, take a moment to analyze this line plot. Each X represents a data point. You could think of this line plot as being a representation of a sample of people's salaries per hour. So where there's an X above $6.25 means that that person earns $6.25 per hour. The X above $7 means that there's a person that earns $7 an hour, etc. So, to find our mean, to understand that there are 5 people that earn $6.25. So 6.25 plus 6.25 plus 6.25, and I do this 5 times. I could have also written this as 6.25 times 5. Next, there are 3 people that earn $6.50. So I have to add $6.50 3 times. One person earns $7, and one person earns $8.25. I then divide that by the total number of data points. There are 10 total data points, so I'm dividing by 10. I now take a moment to add this up. 6.25 5 times, plus 6.50 3 times, plus $7 plus $8.25, which gives me 66 divided by 10, or $6.60. That is our mean. For the median, I would write each number in order from least to greatest and cross off from either end until I find the center. To save some time in our video, I've already written the numbers out in order up here where I have the mean. So I'll cross it off within the problem itself. First and last, second and second to last, third to last, fourth and fourth to last. And now I'm left with my two middle numbers, so I have to find the mean of those two remaining numbers. 6.25 plus 6.50 divided by 2, which is 12.75 divided by 2, or 6.375. So when talking about money, we can round to approximately $6.38. And finally, our mode, or the most popular answer. Since 5 people say they earn $6.25, and there are only 3 people that earn $6.50, 1 person that earns $7, and 1 person that earns $8.25, the most popular answer would be $6.25. Now the question also asks us to decide which measure of central tendency best describes the data. In this case, the $7 and the $8.25 can be considered outliers. Those people make more money than the majority of the people that we surveyed. So I don't think mean would be a very appropriate measure of central tendency for this data. The mode, 625, there are 5 people that earn that, but there are also 3 that earn $6.50. So I would say that the median is probably the best number to describe this data. That $6.38 is a pretty good estimate of what a typical person would earn per hour. Suppose your grades on 3 science exams are 82, 94, and 89. What grade do you need on your next exam to have an average of 9? This type of question is especially appropriate for students, since I always have students ask me, what do I need to get on my next quiz or test in order to get an A? Now you'll know how to figure this out on your own. Let X represent the next exam grade. I defined my variable so that I know what X stands for. So far, if you've earned 82, 94, and 89, plus an unknown score, X, and then I can divide that by the total number of data points. Well, once you've taken this exam, you'll have 4 quiz grades. And we want our total for our average to equal 90. Now I use algebra to solve for X. In algebra, we use inverse operations. So currently, we're dividing by 4. The inverse or opposite would be to multiply both sides by 4. Whatever I do to one side of the equal sign, I have to do to the other. This allows me to cancel out the 4 in my denominator. So I'm left with 82 plus 94 plus 89 plus X, which equals 360. Now I combine like terms in order to simplify. 82 plus 94 plus 89 is 265 plus my unknown exam X. Using inverse operations, I would subtract 265 from both sides. So X equals 95. This means you would need a 95% on your next exam in order to have an average of 90. Pause the screen and try this question on your own. Resume when you're ready. We let x equal the unknown exam grade. So far you've gotten 80, 93, 91, and then the unknown score. You'll have 4 total after you take the next exam, and you want your average to equal 90. Multiply both sides by 4 to get rid of our denominator. Combine like terms in order to simplify. Subtract 264 from both sides. You would need a 96% in order to get a 90% average in class. Find the range and mean of each set of data. Use the range to compare the spread of 2 sets of data. Pause the screen to try this on your own, and resume when you're ready. For our data set number 1, 45, 47, 34, 36, and 38, I add them together and divide by the 5 data points in order to find our mean. And we get 40. The range, which is biggest minus smallest, would be 47 minus 34, which equals 13. On the other side, my mean would be 56 plus 35 plus 27 plus 47 plus 35, divided by 5 data points. This also gives me 40. Our range, biggest minus smallest, would be 56 minus 27, or 29. When comparing these, the mean tells us that the central point of the data is the same for both sets. However, in the data set on the left, the points are much more clustered around the center, since our range is much smaller, only 13. In our second data set, while the center or average is still 40, the other data points are much more spread out, since our range is larger with a 29.